The world saw World War II as a clash of armies, but far from the trenches and tanks, another battle was being waged. A hidden war driven by numbers, equations, and engines that roared like caged beasts. While bombs rained down on Berlin, Tokyo, and London, secret laboratories concealed behind steel doors raced to achieve the impossible: absolute speed. No one knew it, but this race was as deadly as any frontline combat. Pilots died in clandestine tests, and engineers risked their lives trying to tame forces that physics didn't fully understand. Stay with me until the end and see how planes that should never have existed almost changed the outcome of the war, and why their designs were erased from the archives for decades. By 1944, World War II already seemed decided on the battlefield, but inside the hidden hangars of Germany, the United States, Japan, and Britain, the true geniuses of the war didn't wear uniforms. They wore oil-stained lab coats. There, a silent rivalry was born. Who could build the fastest fighter plane in history before the war ended? It was a race against time, against gravity, and often against politics itself. Every nation had its secret, and every secret came at a price. Hitler's Germany believed it had mastered the skies with the Messerschmitt Bf 109, but the high command knew the truth. The design was already aging. The Luftwaffe needed something new, something that defied even the air itself. That's when the name Ernst Heinkel began circulating among engineers like a forbidden legend. Heinkel wasn't a soldier. He was a visionary obsessed with the idea of flying faster than any man had dared to dream. While the regime poured resources into propaganda and parades, Heinkel toiled in the shadows, building a plane that even the generals thought impossible. These tests took place on isolated runways with armed guards preventing any approach. Few knew what was being tested. Fewer still understood the risks. It was common for pilots to receive terse orders. Climb as high as the engine allows, and if something goes wrong, don't talk about it. Each flight was a leap into the dark. The experimental aircraft had no manual, no guarantee of return. The engine could explode, the fuselage could vibrate until it tore apart. And yet, they took off. Meanwhile, across the Atlantic, Grumman and Republic worked in absolute secrecy. American aviation didn't just want to win battles, it wanted to conquer physics. This marked the birth of a new mindset. If the enemy had jets, the United States needed propellers that could compete with jets. And so began the tests of the XP-47J, the Ghost Thunderbolt, a project so classified that frontline combat pilots would never even hear its name. In Japan, something similar was unfolding. The Imperial Army, fearing the arrival of B-29s over Tokyo, quietly prepared high-altitude fighters that would never see the light of day. But before the Americans or Japanese reached the limit, Germany had already come dangerously close to something extraordinary. In 1939, a German plane didn't just exceed all expectations, it shattered the psychological barrier of speed, achieving marks that the Luftwaffe itself refused to acknowledge. The reason? One man's success contradicted the empire's narrative. Rumors began circulating among technicians and officers. He built a monster, a fighter so fast it confused radars, so light it seemed impossible to keep stable, and so advanced it looked like it came from the future. It was the Heinkel HE-100, a plane the Nazi government tried to erase from history, because it would prove the Luftwaffe had bet on the wrong horse. What should have been Germany's pride became a state secret. In official archives, the HE-100 was classified as fake propaganda, but in internal reports, sealed away for decades, there are mentions of flights reaching over 740 kilometers an hour in 1939. No other operational fighter came close. None. If this information had been released, Heinkel's name would have overshadowed Messerschmitt, and Hitler wouldn't tolerate being contradicted. But the secret wouldn't stay buried forever. The project the Reich tried to hide would inspire the Americans, alarm the British, and reignite the race for aerial supremacy. Because when you try to erase an idea, it only spreads faster. And so the obsession of one man, Ernst Heinkel, ignited the spark of the deadliest war of all, the war for speed. But what he created in secret was so bold that the Reich itself called him mad.
Perfect. I'll maintain the same cinematic style and documentary rhythm, but now with maximum historical rigor. Every detail anchored in verified facts, without losing the narrative impact.
In 1939, as Europe marched toward war, one name stood out in the shadows of German aviation: Ernst Heinkel. He wasn't just an aircraft manufacturer, he was a man obsessed with speed, driven by the conviction that the future of aviation lay not in sturdy wings or heavy armaments, but in lightness and aerodynamic efficiency. Heinkel believed that every curve, every rivet, every polished centimeter of metal was a declaration of war against the air. And for a few months, he truly bent physics to his will. Heinkel had founded his company, Heinkel Flugzeugwerk, with a clear goal: to build the fastest plane in the world. While the Nazi government centralized efforts on mass production projects, like the Messerschmitt Bf 109, Heinkel preferred to work on radical prototyping, outside the military routine. That's how the Heinkel H-100 was born, a fighter that not only outperformed the Messerschmitt, but redefined the concept of controlled speed. Its engine was a Daimler-Benz DB601, the same as the Bf 109, but the difference was in the design. The H-100 featured an exceptionally narrow fuselage, short wings, and an evaporative cooling system that eliminated the need for large radiators. This reduced aerodynamic drag and allowed speeds once thought unattainable. In official tests, the H-100 V8 prototype recorded 746.6 kilometers per hour, a world record on March 30, 1939, a figure confirmed by international measurements and held for 3 years. No other operational fighter of the era came close. But technical success soon met political resistance. The Reichsluftfahrtsministerium, the RLM, the Reich Air Ministry, had already selected Messerschmitt as the Luftwaffe's primary supplier. The government didn't want two fighters competing for funds and strategic materials. The H-100 was more complex to produce and required rare metal alloys that were hard to manufacture at scale. Despite its extraordinary speed, the project was deemed impractical for the war effort. Heinkel didn't accept the verdict. He continued developing optimized versions like the H-100D1 with real armament and combat potential. Some of these models were sent to Japan and the Soviet Union for demonstrations, but without follow-through. Realizing his fighter had no future in the Luftwaffe, the regime decided to use it another way: propaganda. Numerous photos of the H-100 were released in magazines and newspapers as if they were the Heinkel H-113, a supposed frontline fighter in operation, complete with fake squadron numbers painted on the sides. It was visual theater designed to deceive foreign observers and bolster the image of German aerial supremacy. The irony is that instead of flying on the front lines, the world's fastest plane was reduced to a propaganda prop. Still, within technical circles, Heinkel's achievement was undeniable. British and American engineers were intrigued by reports of such high speeds in 1939, and many believe it accelerated the Allies' own high-performance fighter programs. The H-100 became a kind of technological ghost, a plane that existed, but no one could openly admit. Behind the scenes, test pilots described unique sensations. The plane was agile and fast, but unstable in sharp turns. The cooling system, though revolutionary, was finicky. A minor failure and the engine would overheat in seconds. It was a machine ahead of its time, but perhaps too far ahead. Heinkel himself said that pure speed wasn't enough. One had to understand what it did to man and metal. When the war began, the Reich's focus shifted to quantity over quality. The H-100 quietly vanished from official reports, and its remaining prototypes were dismantled. The record endured, but the name behind it was erased. Years later, Allied engineers would capture specimens and confirm. The plane was real, its performance legitimate, and its exclusion purely political. Even so, the H-100's impact spread. It influenced later aircraft designs, especially in ideas of clean fuselages and embedded radiators. It was a silent lesson. The limit of speed wasn't just technological, but bureaucratic too. As Heinkel's name faded from reports, American engineers watched in silence, and in a factory on Long Island, a team of designers began building something that would leave even the H-100 behind. A fighter that could fly at 800 kilometers per hour and challenge the jets of the future.
In the United States, the war for speed wore a different face. Unlike Germany, where engineers vied for political favor, the American challenge was industrial. How to turn raw power into control. As the Pacific boiled and Europe's skies filled with enemy fighters, Republic Aviation in Farmingdale, New York, worked silently on a prototype that seemed impossible, a plane capable of reaching 800 kilometers per hour, still with propellers. Its codename? XP-47J Thunderbolt. The story begins in 1943 when Chief Engineer Alexander Kartvali, a Georgian immigrant who believed speed is the best armor, realized that the famous P-47 Thunderbolt, despite its robustness, was too heavy. He envisioned a radically lighter, more aerodynamic version, something that could keep up with even the new German jets. Thus, the XP-47J was born, the boldest piston-engine aviation project in America. The prototype used the same engine as the conventional P-47D, the Pratt & Whitney R2800-57C, but with a dual turbocharging system and water methanol injection, allowing temporary boosts to nearly 3,000 horsepower. The entire plane was redesigned to cut weight, armor was removed, armament simplified, and the fuselage shortened. Even the rivets were repositioned for better airflow. It was a blend of ingenuity and madness. The first flight took place on November 4, 1943. Test pilot Mike Ritchie described takeoff as a punch in the back. Acceleration was brutal. The plane gained altitude like a rocket. In subsequent flights, engineers noticed something no other propeller fighter had experienced: compressibility. Above 800 kilometers per hour, airflow over the wings behaved unpredictably. Controls locked, and the plane dove on its own. It was the boundary between propeller flight and supersonic, and no one knew exactly how to cross it. In one test, Ritchie dove from 9,000 meters and the XP-47J hit 505 miles per hour, 811 kilometers per hour in level flight, an unofficial mark surpassing all records of the era. When he landed, parts of the wings showed compression deformations, and the cockpit smelled of smoke. The team celebrated quietly. They knew they'd glimpsed the limit of the possible. Despite the success, the project fell victim to wartime haste. The XP-47J was expensive and fragile. Its lightened structure couldn't withstand prolonged combat. Republic was already producing thousands of conventional P-47Ds for Europe, and P-80 Shooting Star jets were in the hangars. The piston era was ending before reaching its peak. But the XP-47J's contribution was immense. It proved propellers had hit maximum yield. The plane taught American engineers how to handle compressibility, knowledge essential for early jet fighters. Later, wind tunnel tests at Wright Field confirmed the XP-47J had come perilously close to the sound barrier. Without production, the prototype influenced generations. Many of its aerodynamic principles would be applied to planes like the F-86 Sabre in the following decade. Kartvali himself would later design the F-105 Thunderchief, another speed milestone. The philosophy was the same: harnessing propulsion power through the courage to experiment. Pilots who tested the XP-47J said it was violent but honest. It accelerated like a missile and demanded ice in the veins. It was the final limit of what a propeller could offer before aviation entered the jet age. The project was quietly archived in 1945, but not forgotten. At war's end, a single prototype remained in Republic's hangars, used as a basis for engineering studies. The ghost of a time when the roar of radial engines still shaped battle fates. If you're fascinated by these projects that almost changed history, subscribe to the channel. Here we reveal what stayed hidden for over half a century in the war archives. The XP-47J was the last cry of American propellers, but Germany, even in ruins, still held a secret card. While Kartveli dismantled the prototype on Long Island, engineers in Oberpfaffenhofen tested something that defied all logic: a fighter with two propellers in opposite directions, a front engine pulling and a rear one pushing. The name was enigmatic, and the Allies would only learn it after surrender. They called it the Pfeil, the arrow, a plane so fast it left jets behind, and so dangerous that few survived to tell the tale.
In the final months of World War II, as Germany bled on all fronts, engineers at Dornier Flugzeugwerke still toiled in silence. The Luftwaffe was collapsing, factories bombed daily, but the Nazi command clung to one last dream: to create the fastest piston fighter in history. The result of this almost supernatural effort was the Dornier Do 335, codenamed Pfeil, the Arrow, a plane that seemed to defy all laws of aerodynamics and, for a few moments, truly did. The Pfeil's concept sprang from the mind of Claude Dornier, an engineer known since World War I for his bold ideas and resistance to conventional thinking. He believed the future of fighters lay in combining two engines, one in front and one in back, both aligned on the same longitudinal axis. The unprecedented push-pull configuration in a high-performance fighter promised to eliminate drag from wing-mounted engines while doubling power without compromising stability. It was such a bold idea that even Messerschmitt engineers called it insane. The first prototypes took shape in 1943. Dornier designed a narrow, long, and incredibly clean fuselage for a twin-engine plane. The front engine pulled the aircraft, while the rear one, mounted behind the cockpit, pushed via a shaft and tail propeller. When both Daimler-Benz DB603E engines ran together, the Pfeil delivered over 3,500 combined horsepower. In tests, it exceeded 760 kilometers per hour in level flight, figures placing the DOW 335 alongside the world's first jets. But genius came with absurd risks. The rear engine's position created cooling issues and made pilot ejection a nightmare. If something failed, the rear propeller could shred the aviator mid-ejection. To counter this, engineers devised a revolutionary system: explosive panels that jettisoned the propeller and vertical stabilizer before the seat ejected. It was the first such system in a fighter, something that decades later would become standard in modern jets. Despite the challenges, the Pfeil flew impressively. In 1944, during a demonstration, test pilot Hans Dieterle hit 765 kilometers per hour and reported, "The plane is heavy, but it responds like it has a mind of its own." He landed with wings trembling from air compression and brakes overheated, but alive. What, in that phase of the war, was already a victory. Yet the DOW 335's fate was betrayed by the calendar. It arrived too late. Germany's supply lines were destroyed, fuel scarce, and the Luftwaffe could barely keep its Me-262 jets flying. Still, about 37 units were built, a symbolic number for the scale of ambition. Very few saw real combat. There are reports of isolated encounters with Allied fighters over Germany, where the Pfeil simply vanished ahead of pursuers, leaving them stunned. When Allied forces advanced on German bases, they were shocked to find the DOW 335 in hangars. To Allied pilots, it looked like a machine from another era: front and rear propellers, tricycle landing gear, pressurized cockpit, jet-like speed. The project was immediately seized and shipped to the United States under Operation Lusty, the secret program that gathered Reich aeronautical technologies. One model went to Wright Field in Ohio, where American engineers confirmed the numbers. The Pfeil was indeed the fastest piston fighter ever built. The Pfeil marked the boundary between old and new. It was the last cry of the propeller era and the prelude to the jet age. It showed how far Germany was willing to go, even to the edge of rationality, to try turning a lost war. The Allies realized that if the DOW-335 had been mass-produced a year earlier, air dominance over Europe would have been far harder won. Today, only one complete exemplar of the Pfeil survives, restored and displayed at the Smithsonian National Air and Space Museum in the United States. It stands there as an artifact of genius and desperation, a reminder that innovation can bloom even amid collapse. But while the Pfeil vanished into occupied hangars, the Pacific War still held a secret. Thousands of miles away, Japanese engineers tried the same feat, a fighter to challenge B-29 bombers at altitude. And what they were about to build would make the Allies doubt it was real. They called it Taka no Hare, the Hawk's Wing, a plane Japan denied building, and that for a long time the world believed never existed.
While Germany bet its last chips on impossible projects, Japan, besieged and exhausted, still fought the inevitable shadow of the B-29 superfortress. These bombers flew too high and too fast for conventional Japanese interceptors. The Imperial Air Force needed a miracle, and in the secret hangars of the Nakajima Aircraft Company, a team of engineers believed they'd found one. They called the project Ki-87, the fighter the world would only discover after the war ended. The Nakajima Ki-87 was a direct response to the American offensive on the Japanese archipelago. By 1944, cities like Tokyo, Osaka, and Nagoya were devastated by large-scale air raids. Japanese fighters like the Ki-44 Shoki and Ki-84 Hayate, though fast, couldn't reach bombers flying above 9,000 meters. Imperial Army General Yasuda ordered a new aircraft, a high-altitude fighter, pressurized, armed with heavy cannons, and powerful enough to intercept B-29s before they struck Japan's heart. The project landed with Nakajima, a company with experience in radial engines and supercharging experiments. The challenge was immense. Japan had never produced a pressurized fighter, and turbo superchargers, essential for high-altitude performance, relied on advanced metal alloys scarce due to the American naval blockade. Still, Chief Engineer Koyama Hideo launched the project. The plane featured a Nakajima Ha-4412 engine, an 18-cylinder radial with over 2,400 horsepower, a rear turbocharger system, and pressurized cabin. The blueprint showed an elegant aircraft with a long fuselage and medium-span wings, a blend of the American P-47 and Japanese Ki-84. When the first prototype was ready in April 1945, the country was already collapsing. The Oda factory worked under constant bombing, and aviation fuel was rationed. Even so, engineers managed the first test flight. The Ki-87 took off, but failed to retract its landing gear, a simple mechanical issue, but symbolic. Haste and scarcity were overtaking engineering. Still, the plane flew well. The engine responded, and calculations showed it could reach 700 kilometers per hour at 10,000 meters, unprecedented for Japan. Reports indicate the Ki-87 had potential to outmatch the legendary P-51 Mustang in high-altitude combat, thanks to its power and armament: two 20mm Ho-5 cannons and two 30mm Ho-155 cannons mounted in the wings. But fate was cruel. Only one prototype completed partial flights before being damaged by bombings. When the war ended, Nakajima tried to destroy all technical documents to keep them from American hands. Many were burned, others buried. Even so, the Allies found fragments, parts, and technical reports enough to piece together part of the story. Years later, American engineers confirmed the Ki-87 was real, and its altitude and power calculations consistent. Japan officially denied the program for decades, trying to erase traces of a lost war. But physical evidence, photographs, engine parts, and test records prove the plane truly existed. The Ki-87 symbolizes what Japan became at war's end: technical ingenuity drowned in desperation. It was a plane born in ruins, designed by men who knew they might never see peace. In a letter found after the conflict, a Nakajima engineer wrote, "We didn't build this plane to win. We built it to show we could still dream." In the end, the Ki-87 never faced an enemy. The second prototype, nearly complete, was destroyed before flight. Its turbo-supercharged engine, a rarity, was confiscated and shipped to the United States, where it helped refine future piston and turbojet propulsion projects. Like the Do 335, the Ki-87 arrived too late. It was a ruined nation's final attempt to reach the impossible, and that's why its name vanished from official records. Today, few images survive. A blurry photograph shows the prototype parked, gear down, with technicians around. The last time the plane was seen intact. For decades, historians doubted its existence, until post-war recovered documents confirmed it wasn't a myth, it was one of the last ghosts of the speed race. But the story doesn't end there. As Japanese engineers erased their projects and Germans tried to hide theirs in underground factories, a team of American officers landed in Europe with a clear mission: capture everything. They called it Operation Lusty. In a few months, the United States looted the greatest trove of secret technology in history, and among the captured fighters were plans that would change aviation's future forever.
When the Reich finally surrendered in May 1945, the world believed the war was over. But behind the scenes, a new battle was just beginning: the war for knowledge. As entire cities still smoldered, American and British teams landed in occupied territory with a clear mission: locate and capture all enemy aeronautical technology. The operation's name was discreet, almost innocuous: Operation Lusty. But what it uncovered would redefine modern aviation history. Lieutenant Colonel Harold E. Watson, a test pilot and engineer, led a special unit known as Watson's Whizzers. His task was to find, evaluate, and ship to the United States the Luftwaffe's most advanced projects: jets, experimental fighters, engines, and compression systems unknown in the West. What they found exceeded any expectation: underground hangars filled with aircraft that seemed from another century. Among them were the Dornier Do 335, the FW-152H, and fragments of Me-262 jet fighters. Each plane was a capsule of the future, hidden under the dust of German collapse. Meanwhile, across the planet, American officers gathered the wreckage of the Japanese Empire. In Japan, Nakajima and Mitsubishi technicians were interrogated about prototypes the world didn't know, like the K-87, the J7W1 Shinden, and experiments with German-inspired jet engines. Many engineers, fearing punishment, traded secrets for safety. In weeks, the United States had assembled the largest collection of aeronautical knowledge ever seen. These aircraft and reports were shipped to US and UK research centers. The Do 335 was disassembled and studied at Wright Field, Ohio, where engineers confirmed its speed over 760 kilometers per hour and innovative ejection system. The FW-152H, with performance above 13,000 meters, provided lessons on aerodynamics in thin air. Reports on the K-87 and other Japanese fighters directly influenced American turbojet and turboprop engines of the following decade. The speed race hadn't ended, it had just changed form. The stolen Axis knowledge would seed the next era, the jet age. In 1947, just 2 years after the war, Captain Chuck Yeager would break the sound barrier aboard the Bell X-1, a plane inheriting part of these captured prototypes' legacy. The slim fuselage, compressibility studies, and reinforced metal alloys were direct fruits of 1944-1945 experiments. Many German engineers were brought to the United States under Operation Paperclip, ostensibly for scientific collaboration. Names tied to aviation and propulsion ended up working for companies like Lockheed, Boeing, and North American Aviation. The enemy's once feared knowledge became the engine of American progress. In the United Kingdom, the impact was similar. British engineers studied German BMW 003 and Jumo 004 engines, inspiring the Gloucester Meter and de Havilland Vampire jets. The line between victor and vanquished blurred before engineering. What mattered now wasn't who won the war, but who inherited the science. These secret operations were never widely publicized. For years, reports remained classified. But the effects were visible. In under a decade, the world went from piston fighters limited to 700 kilometers per hour to jets exceeding Mach 2. It was as if the entire World War II had merely been the prelude to a technological revolution starting now, fueled by the same secrets born in German bunkers and Japanese hangars. The Do 335, that twin-propeller fighter, symbol of genius and desperation, would be restored in the United States decades later, now silent, displayed as an artifact in the Smithsonian National Air and Space Museum. Not as a weapon, but as a reminder of what humans can create when cornered by time and war. The secret battle for speed had no clear winners. All lost lives, resources, and sanity chasing the impossible. But paradoxically, from that madness came the future. Every risky test, every pilot who climbed knowing they might not return, every sleepless engineer crunching numbers, they all left a trail that guided aviation into the modern world. If this story showed you how much the war hid from humanity, subscribe and share. There are still classified World War II projects that never surfaced, and in the next video, I'll tell you about one. In the end, it wasn't the bombs that won the war, but the ideas. Speed was the altar, the engineers, its priests, and the planes born in shadow ended up lighting the skies of the future.